Welcome to The Explainer. All right, today we are diving into a huge topic, Kubernetes. You've probably heard the name thrown around, right? But what does it actually do? And more importantly, why should you care? Well, let's get into it.
These days, apps aren't just one big block of code. They're made up of all these tiny independent pieces called containers. It's a great way to build things fast. But when you go from managing just a few containers to hundreds or even thousands, well, as this quote says, the complexity just explodes. It gets messy fast.
So how in the world do you conduct that massive, chaotic orchestra of containers? Well, that's exactly what Kubernetes is for. It's the master conductor. It's the thing that steps in and makes sure every single one of those little pieces is playing its part, all in perfect harmony.
Okay, listen up, because if you only get one thing from our time together, let it be this. Kubernetes works on something called a desired state principle. What does that mean? It means you don't tell it how to do things step by step. No way. You just tell it what you want the final picture to look like. I want 3 copies of my app running. That's it. And then Kubernetes works non-stop, like a relentless thermostat, to make sure the reality in the room matches the temperature you set. This concept is the key to everything.
So how does it pull this off? How does it make reality match your goal? To understand that, we got to pop the hood and look inside a Kubernetes cluster. And we'll start with the brain of the operation, the control plane.
The control plane, yeah. Think of it like an air traffic control tower for your applications. It's not actually flying the planes, your code, but it sees the whole sky. It's making all the big picture decisions, coordinating all the takeoffs and landings, and making sure everything runs smoothly without any collisions. It's the master strategist.
And this brain isn't just one entity. It's actually a team of 4 key components, all working together. You've got the API server, which is basically the front door. All communication goes through it. Then there's etc. That's the cluster's memory, where it stores that desired state we talked about. Next is the scheduler, whose only job is to figure out the best place to run a new application. And finally, the controller manager. This is the real workhorse, the one constantly checking, does reality match our goal, and fixing it if it doesn't. Each one is absolutely crucial.
All right, so we've got the brain, but who's actually doing the work? Who's lifting the heavy boxes? That's where the worker nodes come in. This is the workforce. These are the actual machines, the servers, where your code, your containers, actually live and run. And in Kubernetes speak, one or more containers get bundled together into something called a pod. That's the smallest thing Kubernetes manages. So the worker nodes run these pods, listen for commands from the brain, and are always reporting back, yep, everything's good over here. It's that constant feedback loop that makes the whole system work.
And on every single one of those worker nodes, there's this little agent running called the kubelet. You can think of it as the on-site foreman or manager. It gets its orders from the control plane, the main office, and its job is to make sure all the containers on its machine are running and doing what they're supposed to be doing. It's the bridge between the big decisions and the actual work getting done. Okay, so we've got the brain, we've got the workforce, they're all talking to each other. So what? What's the big payoff here? Well, it all boils down to one word: automation. Seriously powerful automation. This is where Kubernetes goes from being just a cool piece of tech to something that feels, well, kind of like magic.
Let's talk about one of its most amazing tricks, self-healing. Look, in any big system, stuff breaks. It's just a fact of life. But imagine instead of your phone buzzing at 3 a.m. to tell you something's down, the system just fixes itself. That's Kubernetes. It doesn't wait for a person to wake up and figure things out. It sees a problem and it just handles it automatically.
And here's how that works step by step. Let's say one of your app's pods just fails, crashes, gone. That controller manager, the one always watching, instantly notices, hey, the reality here doesn't match our goal. So it pings the scheduler, which finds a new home for a replacement. And just like that, poof, a brand new healthy pod spins up to take the old one's place. This can happen in seconds. Your users, they probably never even noticed a thing.
But being resilient isn't just about surviving when things go wrong. It's also about handling it when things go right, like really right. What happens when your app suddenly gets a huge burst of traffic? Can it handle the success? With Kubernetes, the answer is yes, thanks to its elasticity. There's a specific tool for this called the Horizontal Pod Autoscaler, or HPA for short. It's another one of those smart control loops. It's constantly watching things like how busy the processors are. And if it sees the load getting too high, it automatically adds more copies or replicas of your app to handle it. And when traffic dies down, it removes them.
It's all about matching the resources to the demand. Perfectly.
So let's play this out. Imagine a huge wave of traffic suddenly hits your website. You've only got 2 copies of your app running, and they are just getting hammered. Their CPUs are pegged at 95%, and things are starting to get slow. Your users are not happy.
But check this out. Before your monitoring system can even send you an alert, the HPA has already seen the problem. It springs into action and automatically doubles your app's capacity to 4 pods. The load gets spread out, CPU usage drops back to a nice, comfy level, and your site is snappy again. That's elasticity happening automatically without you lifting a finger.
Okay, so this all sounds amazing, right? Like you just hand your app over to Kubernetes and it takes care of everything. Well, not quite. It provides an absolutely incredible framework, but it's not a mind reader. Real resilience is a partnership between you and the platform.
For starters, your app needs to be a good neighbor. You have to give a Kubernetes some ground rules. You need to tell it, hey, my app needs about this much CPU and memory to get started, that's a request, and under no circumstances should it ever use more than this much, that's a limit. Why? Because without that limit, one greedy application could suck up all the resources on a machine and take everyone else down with it.
Next up, health checks. You have to teach Kubernetes how to tell if your app is okay. The first kind is called a liveness probe. This is literally Kubernetes poking your app and asking, yo, you still alive over there? If the app is totally frozen and can't even answer, Kubernetes knows, okay, this one's a goner, and it restarts it to get it back on its feet.
Then there's the readiness probe. It's a different but equally important question. This one asks, are you ready for business? Can I send you customers? See, an app might be alive, but it might still be starting up, loading data, whatever. This probe makes sure that Kubernetes doesn't send any traffic its way until it's 100% ready to handle it. No more sending users to a half-baked application. So let's wrap this up. What are the big takeaways? First, Kubernetes is declarative. You tell it the what, not the how. Second, it's like a living system, a brain, the control plane, directing a workforce, the worker nodes. This gives you amazing built-in automation like self-healing and auto-scaling. And finally, and this is so important, it's a partnership. To really get all that power, you have to do your part by setting resource limits and defining those crucial health probes.
And that really leaves us with one final thought. Kubernetes puts this unbelievable power for resilience right at your fingertips. But here's the question you have to ask yourself. Are your applications actually designed to take advantage of it? Because the true magic happens when the platform's power meets an application that's built to thrive in this kind of dynamic, automated world.